I'm Ed Brand, sales engineer for RaySafe. I've been with the company for about 23 years and started in the industry in 1988.
I'm Justin Ross. I'm a product specialist with Fluke Biomedical and RaySafe, and I'm not even as old as Ed's been here. I've been with the company for about 7 or 8 years. So we got some good information for you today. This has been a really fun webinar for Ed and I to work on, and I'm really looking forward to presenting this to you. If you do have questions, sincerely, please post those questions. We want to answer as many as we possibly can, as we've had a lot of fun putting this together. And I think that's back to you, Miss Edna.
All righty, let's check out this demo.
Alrighty, so here we are, Ed. We have our RaySafe X2, and this is the standard aluminum case that ships in. I've always liked this case because I feel like when I'm walking around a facility, I'm just a chain away from feeling like I'm a super secret spy, undercover agent guy, and it just makes me feel kind of cool as a tech. Little geek up point. But we want to take 10 seconds and go through the RaySafe X2 case and show everybody what's in it, because, you know, I demo this a lot with customers, and amazingly, even customers who've been carrying it around for years don't realize there's some hidden gems in here that they might not have known about. So let's take 2 seconds and let's go through the case, and we'll show everybody what comes in it. This is what we call our prestige kit, meaning that it is a full kit. It has the base unit and multiple sensors. A great feature of the X2 is you don't have to have a prestige kit. You might want to buy the base unit and an RF sensor, or a base unit and an RF and CT, or we even have the Solom style kit where it's the base unit and that one specific sensor only. So there's lots of different options. A great feature again about the X2 system is that we can build it to your specific needs. Alrighty, let's go through the kit here. So we have our X2 base unit.
Yeah, the base unit is the heart of the system.
Heart of the system.
Everybody needs a base unit.
Everybody needs a base unit. And we'll go through the base unit more, but some great features are nice color touch screen, easy to navigate. This is where you're going to connect your sensors, ability to bring in a mass port, charging and COM ports, the power button. You got to have the power button.
Yeah.
But there's some hidden features and hidden gems in this that we're going to cover here in a little bit. Underneath the base unit, there are 2 slots. Now, this is where this is kind of cool. In this slot should be a thumb drive. Now, the reason I haven't replaced it is because that thumb drive houses are free. How much, Ed?
Free
RaySafe View software. Now, even though the thumb drive's missing, the reason I don't worry about it is because you can just go to the RaySafe website and download the software. You could download the software today, even if you don't have an X2. Won't do much good, but you can have it. Free. Beside it is the next. This is a bit of a myth. People always tell you about how the X2 is not wireless. Well, believe it or not, this is a Bluetooth adapter that once you plug it into the base unit, makes your X2 wireless. And we'll talk more about that because everybody's saying, hey. We'll talk about that here in a minute.
Yeah.
Now, you want to go through the sensors?
Well, sure. Let's start with the RF sensor because that's the most common sensor that everybody uses. So the RF sensor is useful for radiographic and fluoroscopic measurements, but it's also useful for KVP measurements for CT, dental measurements, all parameters, and also mammography measurements over 40 kV. Then we have the MAM sensor. The MAM sensor is useful, of course, for mammography measurements. So it measures all the pertinent parameters for mammography. We have the light sensor, measures luminance and illuminance.
That's really cool. Also, a neat little feature about, show where the little button is.
There's a button on the top that when you push it, it stores the measurement. Of course, that would be connected to the base unit.
It does have to be connected.
It does. We have the survey sensor. So let me just move these 2 out of the way. And the survey sensor measures leakage and scatter in the diagnostic energy range. Put these back. And the CT sensor is, it's actually an ion chamber, and it is actually used to measure dose in a CTDI phantom, which will come up in our next one of these subsequent episodes of these demos. And last but not least, so this one is an older case. It doesn't have a slot for the volt sensor, but we also have the volt sensor, which was used to measure voltage, of course. It can be used with a Prova 15 current clamp to measure MA non-invasively.
This is a new way that some of the manufacturers want to measure mass. And so I got to tell you, when I first heard about the new way to measure mass, it took me about 3 days to remember how to set up my scope meter. With this volt sensor, it's simply click and play, and you're ready to go taking the measurements, and you don't have to remember all the trigger sources.
Exactly.
For that scope meter. So
Right. Yep.
Now I want to take back here from Ed, because this is something special for me. This is the power cord. And you say, well, what's great about the power cord? I haven't had one for 2 years. The reason I haven't had one, I had to ask for 1 year recently. The reason I didn't have one is because when I was traveling, I could use the cables that come with the X2. They're located up here. The green one, which is
2 meters.
2 meters. And the blue one, which is
5 meters.
5 meters. So when I drive in between demos or service calls, what I would do is I would take these cables and plug in my base unit to the charging port, and then plug this into the USB port in my car, and I would charge my base unit in between service calls. Or if I'm using that free RaySafe View software and I'm plugging in to pull things off and on the base unit, as soon as I plug this into my PC, it's also charging it. So I honestly never worried about the charging port until we had to do the video, in which case I did get a cord, because I was always plugging it into something and charging it on the way. So these are great. I should also mention about these cables. If you break the cable, eat the cable, lose the cable, please don't eat the cable. That'd just be weird. Whatever happens to your cable, it's not a big deal. Just go get yourself a micro USB to a USB-A cable, and you can keep on moving. The only thing about these ones is they're color-coded for the lengths. But if you do that, please make sure you get a good shielded cable so it helps for your X2 give better readings.
Yeah. So since we're on cables, why don't we address the other cables?
Yeah.
So we'll start with this one, Justin, because
since we're talking USB.
So this is an active USB extender. I believe it's 10 meters long, and it can be used in conjunction with either of the two cables. So in this case, it would be 5 plus 10 is 15 meters. And here we have 10 plus 2 is 12 meters. And it can be used in between to connect the base unit to a sensor or your base unit to a PC.
Correct.
If you have two of these, you could actually have up to, I suppose, almost 30 meters distance between the sensor and a PC.
Very handy to have.
Yes.
Especially if you're working in a vault, like with a Linac machine. These are great because you can run these through the wall, through the tubes in the wall, and then leave it in place.
Actually, there's another way to do that too, is the Ethernet port. We're not going to show that right now, but you can use Ethernet cable too, which we don't supply, but everybody has Ethernet cables.
So really cool. Hey, wait. You know something else that's in here? Oh, wait, do that cable.
Well, this cable first. This is for the mass. So Justin mentioned that we have the mass port on the base unit, and if I connect that and connect the terminals here to the test terminals, the mass terminals on the generator, you can measure MA and mass invasively. And then we have the calibration certificates also.
So those are cal certs
in the pocket, and we have keys. I don't know that anybody's actually used the keys, so I won't even take them.
Unless you're being super secret undercover agent spy guy.
Exactly, and it's that attaches to the key.
Yeah, we didn't pull the strap out. This is kind of nice because, if you're trying to carry a lot of things down the hallway, it clicks right onto the side of the case, and you can throw the case over your shoulder and free up your hands. That's also nice.
So
hold on, we have one more
thing. Oh yeah, there's a piece of aluminum. So if you have the MAM sensor, you're going to get this 2 millimeter piece of aluminum, and this is used when we measure kV specifically on the Moly target rhodium filter. So Moly rhodium kV measurements, you use this and you set this on the compression panel.
Cool.
I'll throw that back in.
Yep.
Otherwise we'll lose it.
So I'm going to push this up here just a little bit because now I'm going to get into my favorite part in the case. So up here in this top corner, right here is an unsung hero. A lot of people don't know what this little adapter is for. So we're going to talk about that, but to get to it, underneath our CT sensor are two aluminum rods, 1 and 2. All right, Ed.
All right.
So remember, this is our bait and switch. We're going to wait for you guys to show what this is about, and we're going to talk about these two aluminum rods.
Exactly. So the rods are a piece like a flexi stand. So we have two components. We have the base and the top of the flexi stand. So originally the flexi stand, in a previous iteration, actually for one of our earlier models that couldn't measure HVL correct or automatically, we had it configured as an HVL stand. And you know that piece of aluminum that I just put up there, we'd put that on top. So we would make an exposure with the RF sensor, for example, and then an unfiltered exposure, and then we would put the aluminum on top, make another exposure, record the dose, make another exposure with more aluminum, manually calculate the HVL. We don't do that anymore because the HVL is automatically calculated in the RF sensor.
So then why do you need a stand?
Well, because it's 30 centimeters. How many inches is that?
About 12 inches.
Right, 12 inches. So 30 centimeters high. So many times you need to measure the dose rate on a fluoro system 30 centimeters off the image detector. And so this is 30 centimeters. And this places the sensor at exactly 30 centimeters above the image detector. So there you go.
So you can do that with it.
Yes, you can. What else?
Or,
yep.
Now we have our aluminum rods out there. Here is another holder that we have in, and this is a sensor holder. You can put the sensor in it like such. Actually, let me got the screen cable here around you.
Mm-hmm.
So if you connect the cable like such, and then you can put it into this holder.
Yep.
And it will go through, and the cable will go through like that. So it's a cable stick.
Screw that in there.
Yep.
So I might as well do that right now.
Do it right now.
Operation. Thanks for holding that.
You're welcome. So now there's a neat little trick that you can do with this. This is a great holder, and if you want to just look at the flexi stand, if I have the base like this, I reach back into my case, and I'm going to get my twisted turnout device.
Which is actually just a clamp.
Yeah, twisted turnout sounds more better. Anyways, it is an adjustable clamp. So you can take your twisted turnout device, and you can put your arm through like this, and tighten this down. And now you can position your sensor wherever you might need it to. Let me turn it this way so you can see better. There you go. And if I need to adjust the height, I loosen it up. And I can adjust my height up or down. I can move it around. However I need to position my sensor. Maybe I want to pull it in a little bit more. Right. So that is part of the flexi stand as well. Now let's get into a different trick. Let's talk about low dose and the RF sensor.
So if you need to measure low dose, you can remove this and you can actually connect these two rods together. So please hold this as
I will hold this one.
Unscrew this.
You guys think we're forgetting about this?
No, we're not forgetting.
This is your cliffhanger.
No, this is the cliffhanger. So now we're going to connect the two together.
Now as he's connecting that, inside the box there's these two little rubber blocks. And these two real rubber blocks have a few usages. The one I like to use, in this case, I have this cable that I have to be mindful of. So I can take these little rubber blocks and stick them over top of the rod like this, and maybe another one down here. And I'm going to use those rubber blocks as a cable stay.
So this was originally designed to measure the dose. You put it in the Bucky, measure the dose to the Bucky tray. Justin has another alternative use, which is to measure fluoro low dose. Maybe the tube is pointing up. You just flip it over and put the sensor right on top of the tube. And measure low dose rate fluoro.
You can reach right around the side of the Bucky and set this right on the tube. So if you can get enough dose to it, in her square log, just simply get the sensor closer to the tube. It's hard to reach in there. You don't want to crawl underneath the table. This gives you a great way of just reaching around and sticking it onto the table.
So the intended use of these little rubber blocks,
doodads,
I'll call them little rubber blocks, was to prevent the sensor from rotating. So if you're hanging, if there's a need to position the sensor off the edge of a table or, then one of those urology x-ray machines, I forgot what they're called. They have the hole in the center. You can position it over in the center of the hole, and this would prevent it from rotating.
That's correct.
Yep. So we have that. Oh, what am I missing?
So I found out I was working on a cath lab with a customer, and we didn't have the right adapter. So over the cath lab, you have to put a filter over the II, because when you're doing the calibration, so you don't burn out the II. And there is a holder built to hold your sensor there. But the problem is our rod is the wrong diameter, and we didn't have the correct holder. So instead of going home, we figured out if we put these two little rubber blocks on here, because these squish and compress, I was able to click this into place on that II filter.
So you're a pro at discovering alternative solutions.
I'm telling you, for two little rubber blocks,
uses, yes.
there are all kinds of alternative uses for these two little rubber blocks.
I know you like rubber blocks, but what's your favorite?
Okay, so here's my favorite. So back to this little itty bitty little guy. So this is forgot about in the top corner of the case. It's usually, like I said, it's supposed to be sitting up there in the corner, but sometimes they disappear. What this allows you to do is to take a simple tripod. This is not a fancy tripod, trust me. And it's a tripod adapter. So it's got the threads to connect onto a standard film tripod.
And let's say you wanted to measure leakage and you don't want to be in the room as you're measuring leakage.
Correct.
Tube leakage, for example. What would you do?
So I
probably use your survey sensor.
So my survey
I guess
sensor.
I'm stealing your thunder.
You're having fun.
I'm having fun. So you position this as such. And that's a little high, but yeah, you can position this. Of course, the cable, you'd run that through. Yeah, you should always probably connect it before you put it in. But
See, you got so excited to steal my.
I did. I
Still my thunder.
Sorry about that.
It's okay. I'm happy to share. So you can do this, but you know, if you get the bigger tripods, these are great because then you can put this out this way or on the side angle and connect it to that tripod. And it really does make it convenient for positioning either your survey paddle or your CT probe, and you don't have to hold it. It's just a great adapter, real unsung hero that lives in that top corner of the kit, and it gets forgot about a lot. All right.
Hey, let's not forget this special hinder, which isn't.
So it doesn't come with the kit, but if you look here in our X2 kit, there's this little hole.
There's a little slat for that.
There's a little slot for that.
And this is a section cut holder.
So let me get that piece of aluminum plate out again.
Yeah. So
Maybe. There it is.
I'll use the RF sensor and I'll stick that in there. So what I've done is I just with this RF sensor, and of course there'd be a cable. But if I stick it to this table's textured. So I just trying to stick it to this piece of aluminum to show that it does actually provide a fair bit of section and a little difficult to get out, disconnect. But then we also have.
So now we have another case to show you guys. Now,
the other case, right?
this was our standard aluminum case, and I am not going to close the lid on this case because this case has been well loved and shipped a lot, and it's got a few dents and dates in it. So give me 1 second here. We'll take this case off the table, and we're going to show you our other case that is available. This is our storm case. Now, the very first thing to say about this storm case is I will close the lid on this because what I want you to see is the fact that in this storm case, it is covered with tape and schmutz. I have had this case for about 5 years, and if I had to wager a guess, I have probably shipped it through 100 times plus between customers and trade shows. So this is what we call a storm case. You can buy it at the time that you buy your X2, or you can add it later on, but it's a durable case. Very rugged, very durable. And what I do is once I seal it up, I put 2 wire ties through it, and I just tape my label right to the box, and I ship this. So that's why I'm going to show you. You can tell it's been shipped many, many, many times. And as sure beat up as the exterior of this case is, it has done a phenomenal job of protecting my X2 that's inside of it. So you can see we have lots of film up here to protect it. Our calibration certificates, all of our sensors are right here. And then underneath, you'll see that we have a little bit more storage. So here's our flexi stand parts and pieces, our charger. Here's our tripod adapter, our rubber blocks. And then there's an additional storage container. So if you're traveling a lot and you want to carry some extra things, like maybe your panoramic dental holder, maybe your vacuum holder, and we'll talk about this for 2 seconds, and maybe your DXR ruler. There's all the rest of our cables. Here's our adapter cable for our volt sensor. Everything has a nice little spot. You can stick it in here, tuck it back into the case, and let's show this for 2 seconds. We're going to cover this in a later webinar, but I love this thing so much because I can put it down and vacuum it to the table, stick my RF sensor in here, and I can adjust this to whatever height I need it to. This is a great holder. Again, it's called our vacuum holder, not to be confused with our suction holder, but a really fun, really useful tool. So, yeah. Release that. We'll stick it back into this case. So, hey Ed, I have heard from our customers that some people are claiming that our X2 system is not truly wireless. Let's talk about that for 2 seconds. Alrighty, so we have our base unit and you have it hooked up with an RF sensor and the Bluetooth adapter in the top. And then I'm going to add this laptop. And this is just a laptop I like. The reason I like it is because when I'm moving around a lot, if I have a tether on the ground, it's something for me to run over. So I like the ability to take my results here and wirelessly transmit them to my laptop. Now, the nice thing about this laptop is because I'm always concerned about space and things I have to carry around, if I'm just taking exposures, I don't even need this keyboard. I can simply do this, and now I just have a tablet, right? Making even less for me to carry and have to worry about. So Ed, let's talk about real quick why we don't want this sensor to be wireless to the base unit.
If we had this sensor being wireless to the base unit, it would need a big battery, right? So let's look at our competition and what they have to offer and the big battery that makes it not radio translucent. There's just no way around it. Now, this cable's 2 meters. I could buy a very short cable, plug it in. Takes what, 5 seconds?
Yep.
5 seconds, you have basically a wireless system. And if your computer should happen to lose charge or whatever, you still have the base unit display in a pinch, right? So that's great. So now we have wireless communications to the laptop, basically a wireless system.
And I really do like this because if I'm working on like a cath lab or something, it's easy for me to have this out there, get my beam alignment, take a little bit of measurements, and then I can use the transmission to wires to go from here to my base unit back in my control room. So now let's zoom in on this just a little bit and let's show everybody. So I'm connected here on my base unit. If you look right here, it's connected by a Bluetooth sensor. I'm going to select this and then let's go ahead and take an exposure.
So I have this in demo mode, so we're just going to simulate an exposure. Probably just 100 kV red shot is good for this purpose.
And now everything that's on here is now on my Surface, on my Surface tablet. And I'm able to see everything in here nice and easily. Everything's been backed up on here as well. So this base unit saves 10,000 results internally.
Yep.
But, so it's saved here. So if my battery's dead here, I can still use this. But again, in this scenario, I'm in a control room with this. I'm taking my exposures. I can see everything here. And I can simply enter these configurations or these results back into the system, do the calibrations that keep shooting versus walking back and forth. I don't have to have it, but it's definitely a nicety.
Yep.
And I can have my alignment here, and everything's nice. And another really cool feature, and we'll go more into this software, is I can see my waveforms here. I can also see my waveforms here.
Right. Exactly. So I think to summarize, perhaps radio translucent, no battery, can have a short cable, wireless to the PC, running RaySafe View. Acts as a remote display, allows you to view waveforms, allows you to connect with Excel, which we show, I think, in a later episode.
So that's 100%. You know, I just thought of something we didn't talk about, I don't think, is this base unit has a 10-hour battery. If you're running at full speed, non-stop, it's about 10 hours. If you're just in idle mode, you get around 20. You get significantly more, up to about 20 hours running it on average usage. And I mentioned that I never carried around a power supply. And one of the reasons I didn't bother carrying the power supply is I can plug this into this port into my PC and be charging it as I go. If I had a battery for this and my battery were to die, I'd have to wait to either change that battery, which sometimes you have to carry.
That's right.
or charge it back up. Even if this battery were to die on this, I can plug it back in with my USB-C port or into my power cord, and I can continue to shoot as I go.
Exactly.
So again, this is the only thing that's in the view or in the field. This can be anywhere nearby, plugged in, unplugged, and still be transmitting wirelessly to my PC. So in all sincerity, if I really needed to, if I plug my PC in the control room, I could run it definitely. 3 days, 4 days, 10 days, 40, that'd be a long calibration, 40-day calibration. Anyways, the point is, how much power do you need?
Yep.
We got it.
And don't be fooled by specs. We say 10 hours of intensive usage in our specification sheet. That's 10 hours, like you said, constantly making measurements.
Correct.
Some of our competitors say a longer battery life, but they say normal usage. So what's normal usage? Not 10 hours per day, right? It's just not normal.
Yep.
So it's just semantics, I think.
Semantics, yep. We should also mention, if you get the service program with it, that battery's taken care of. So if it does wear down, the service program covers getting a new battery.
Yep, it's true.
All right, hey, let's dive into the RaySafe View software a little bit. So I'm going to go ahead and we're going to shift over to another computer so we can see the RaySafe View software and see just how powerful this software really is. All right, so we left off showing you how we can capture some results with the RaySafe View. Now we're actually into the software. So this is the free RaySafe View software, and Ed's going to go ahead and drive the ship. And let's go ahead and start and open up a new file, Ed, and show them what it looks like capturing some data right into RaySafe View and some of the things you can do with it.
Yeah, so when you start RaySafe View, you get a start button. You can open up an existing file. You can import data from the instrument if you had an instrument connected, which we will do in just a few moments. Also, here's a list of recent files that you could open. But anyway, we're going to start fresh, so we're going to hit start. And if you notice, I don't have any instruments connected. So the first thing I'm going to do is connect my base unit to the PC.
Now again, this can either be done through a Bluetooth adapter, which you saw us do there when we're connected to my laptop. Now we're connected to my desktop, and so this time we're just going to go ahead and use the charging port. And the reason why is because I want to charge my base unit while I'm pulling up some data.
So the charger port on the base of in your base unit is called charger/PC. So it either is used to charge the base unit battery, and at the same time can be used to connect for data transfer from the base unit to a PC. So now you see that the base unit appeared, and now I'm going to go ahead and connect an RF sensor. And in a moment, you will see that automatically is connected. All right, perfect. Okay, now I'm going to put my base unit in demo mode so I can...
We're still not allowed to have a rad floor room in my office.
Right, so here we go. So now you see that the X2 RF sensor is in demo measurement mode. So now we are going to simulate a measurement, and you'll see data populate, and you'll see the waveform, the visual of the waveform populate. So now I'm going to do a rad 100 kVp exposure, and there we go. So I could do another one, and I will just do that. And we are going to do this time an 80 kV. So now you see this. And Justin and I wear glasses to write.
All right, just throw me under the bus.
Yeah, well, this one, obviously, it's a large screen. I can read it. We're recording. But
I like this view better.
This view is much better for me and for Justin.
And the reason for me is because everything's in the same exact spot as is on the base unit.
It is, which all these cells are in the same exact order here as they are on the base unit. So we have the KVP measurement, the dose, the exposure time, the HVL, et cetera, all the same as it is displayed in the base unit. And we also now have the ability to see the waveforms. So in this case, the blue waveform is the tube voltage or the KV waveform, and the red is the dose rate waveform or the radiation waveform. You can do some basic analysis on the base unit, but you can do more in-depth analysis. Let's say I want to make or establish a region of interest. I'll just hit the shift key create a region of interest, and now it shows the duration of the region of interest, the start time, the stop time, the min and max and average KV, and the min, max, and average, and the integrated sum of the dose. And so now, if I hit escape, I'll clear that out. And let's take a look at this lower section. Here we have, this is the second measurement. So measurement number 2 taken on this date and this time. We have the X2 base unit serial number. We have the RF sensor. This is a simulated RF sensor, not a physical one.
So that's why the operation's a little bit weird.
Yeah, that's 42 is the answer to everything, right? So,
but this is nice because if you're following an ISO certified for the program and for some reason at the end of the year your sensor's out or you broke your sensor and you want to go back and see how many tests you did with that sensor, now you can go back through your data and find each and every exposure you did with that particular sensor. Because like I said, every now and again, Ed and I have a tendency to trade sensors, or I borrow one from him and I plug it right in my system and it will log the new sensor's serial number. So I'm not stuck with just that one specific sensor.
Right. We have the units of dose, the stop delay setting. We didn't talk about that earlier. Ignore pre-pulses. We didn't talk about that. But one of the nice things too is you can add notes in the base unit. And when you do, they're preserved with the exposure data in the base unit. But sometimes you don't have time, where you just, it's maybe difficult to type in the base unit. So maybe it's easier to use the keyboard connected to your laptop, and we could write just a test note. And now when I save this later on, this note will be associated with this exposure. In fact, you can see the little icon now indicating that there is a note attached to this exposure.
I didn't know if that's what that meant.
Yes, that is. Ooh, I love this. Yes.
Learning it in the webinar.
Right. Exactly.
So if I want to save this exposure, Ed, how do I do that?
I would go up to the save, but let's first connect this to Excel.
Ooh, okay.
So let's save that later. If I hit connect, if I have Excel open, I could choose to connect to an existing spreadsheet. But since I don't, if I just hit connect, it'll open an Excel spreadsheet for me. And then I can choose my workbook. Since this is the only workbook open, it defaults to book 1, sheet number 1, starting cell. I can make this anything I want. I can export all the data. I can export only selected data. And I can, if I mess up, I can use the back arrow to delete that from not only RaySafe View, but also from an Excel spreadsheet. And then I could also use the forward arrow if I decide I didn't mess up and I want that data back.
So wait a minute. So if I was a physicist and I had an existing Excel spreadsheet that I've been using forever to put my data in, you tell me I can auto export as I capture right into that Excel spreadsheet?
Yes, that's absolutely true.
Okay, so what if I didn't have an Excel spreadsheet and I want to find one?
You could download that from actually there's a link here in the file. We could download it from our website, or there's this handy link that points to our website, download Excel templates.
And you can download common templates right there.
Yes.
Change it for your purposes.
Absolutely.
Customize it to your needs.
Yep.
And then automatically, as you're capturing the data, insert it into it.
That's exactly correct.
For free.
For free. Yep. So let's say I want to go ahead and export this data to Excel. So what I would do is I could choose, again, I'll export all the data in this case. You're jumping ahead.
Oh, sorry.
So Justin just jumped ahead, simulated another exposure, and now you can see that that exposure data automatically was populated. So as long as I have auto export measurements to Excel, I can simulate another exposure and I will do something completely different. I'll do a 90 kV rad shot, and now there you go. Okay, now
we have data points.
Now we have data points. And now if I bring up Excel, you will see that the last two exposures, the ones that we just simulated, are exported to Excel. Now let's say we didn't like that. Let's say we go back to RaySafe View and said, you know what? I didn't want those last two exposures, Justin.
Because I was button happy.
You were button happy. So if I go back, I can clear those two out of Excel, and they're gone. Okay? So now, if you notice, it also made the starting cell back to A1. So let's go and let's say I want to export all this data now to Excel. We have backwards compatibility for formats to Excel, the exporting format from XI View, which was the predecessor to RaySafe View. XI View was used with the RaySafe XI. X2 View is meant to be used with the base unit or the X2 system. So I'm going to change this to X2 format. And I'm just going to export all the data. So if I click on the export button, you'll see that the data is now written directly to Excel. Now, if I want to make another exposure,
Okay.
concentrate on row 5. And if I make a dental AC exposure, something completely different, you'll see that that data is now populated in row 5. So I can export data after each exposure automatically, or I can have my measurements in the session exported at the end. I can manually export them.
Yeah,
That's two ways to interact.
I got a question for you. Say that I'm out in the field and my laptop battery's dead.
Yes,
So I wasn't able to auto export today.
right.
So what do I do about that? Is there a way I can save all the results and then export later?
Yeah, there is. Because the base unit stores all the measurement data, right?
Yep.
So I can import data from the base unit. So let's do that.
Let's do
All
that.
right.
We only got a few minutes left, but let's plot through that real quick.
Okay, we'll plot through that real quick. Just think on other systems, you can't do that. If your laptop crashes, theoretically, you could lose everything. But because the base unit stores all this, all I need to do is, or stores all the measurement data up to 10,000 exposures. I can click on File, I can import from Instrument, and I can look at the calendar. And the calendar, where the date is highlighted, that indicates that there's stored data. So I'm just going to pick a session from earlier today and import that data. So I'm going to import this data, and you'll see now that that data is imported to the appended at the bottom. Or actually, I'm sorry, at the top, 4 p.m. There's 2 exposures. And what I can do is I can highlight those 2 and export those to my Excel spreadsheet. Actually, there's 3. Can't count. So if I export those 3, those will now go here. So there's many ways to work with this. It's very flexible. You can have your own templates. You can create. Excel is well known. It's by far the world's largest used spreadsheet in the world, right? Microsoft's not going out of business.
No.
You're never going to lose support for Excel. There's millions and millions of people that you can consult with to develop your Excel templates. Even if you don't like the ones that we provide as demos, you can easily find people to develop them for you. You're not reliant on proprietary software.
Nope.
You don't need to use RaySafe View. You still have your base unit. If all you're going to do is make a few exposures, it might be faster just to write them down.
So we're wireless.
Yep.
But you don't have to be wireless.
You don't have to be wireless.
You can be tethered, you can not be tethered, you can be wireless, you can be not wireless, you can save the data today, you can save it tomorrow, you can pull it from BIAT. Pretty much, we can do however it needs to be done for your application, as well as add in the notes.
That's right.
Is there anything else you want to show from RaySafe View for right now?
Not that I can think of. Do you have any other questions?
Yeah, let's hold up from the RaySafe View and let's go back to the unit one more time, and then we'll open up for some questions.
Sounds very good.
All righty. And with that, Miss Edna, do we have any questions that have come in?
Of course. Yes, we do, Justin. Yes.
I
What a
like
great presentation. Justin and Ed, lots of information. So thank you for that overview. Our first question relates to, you talked about the case a little bit. And so the first question that came in is, can you choose which case you would like to have with your system, or does the metallic case and the storm case come at different prices?
That is a very good question. So on my desk, I have both of the cases. So traditionally, if you buy the stainless, when you first buy your X2 system, it comes with a stainless steel case. There is an option where you can upgrade to the storm case at the time of purchase. So you would get this case instead of the stainless steel. So you can upgrade it at the time of purchase and get this case instead of the stainless steel case. Or for everybody who already has their X2 out there and they say, hey, I really like that storm case, I want to see how many stickers I can get on mine, you can buy the storm case later on. So you can buy it again. We are here to make it however you need it in your world.
Wonderful. Ed, any insights, any additional comments on that from you?
No, I think Justin did a wonderful job.
Okay,
It's your
wonderful.
choice.
I practiced that.
Our next question relates to the tripod. Does the tripod adapter work with any tripod?
It has worked with all the tripods that I have found. Now this is a tripod that you saw that we used, and this is just a cheap throwaway, small little tripod. I have some bigger professional grade tripods in my office for hanging my big cameras and mic boom systems. And it's a pretty universal adapter. So most AV tripods, that will screw right on. So again, depending on your application, if you need a longer one or a taller tripod, it should pretty much screw on most common camera tripods. And it's right here in the case.
Okay, great. Oh, okay, wonderful.
It is your favorite accessory, Justin. So.
It is, well, yeah, well, that one and my vacuum holder.
Yes.
Yes. Yep.
Okay, our next question is, this relates to the sensor. You mentioned the sensor is translucent. What does that mean? And why can it not be all wireless and still be designed to not affect the AEC, ABC?
Oh, well, I'll take that one, Justin, if you don't mind. So, yeah, so we alluded to that, I think, during the video. You need a battery if you want to make it wireless, and that would then prevent it from being translucent or transparent to X-rays is basically what that means. And you want it to be transparent to X-rays if you're making measurements with AEC and ABC for fluoro, right? So you don't want to influence or drive up the KV and or the MA on the ABC system. A battery would certainly do that. Or you don't want to affect the exposure time on an AEC rad system. So it would certainly do that if the sensor was accidentally positioned over one of the ion chambers that control that. But you know, with the RF sensor, it's basically transparent, so it won't affect any of that. Or if it does, very minimally.
Okay, wonderful. Thanks, Ed. In your documentation, you mentioned minimum manual settings. Can you explain what enables that?
I think it's the robust algorithms in the sensor itself, the robust design. We have a wide range. We can measure KVP with filtration, the wide range of filtration in the RF sensor, and also the MAM sensor. You do have to choose your target filter combination if you're measuring KVP on your MAM sensor, but if you're just measuring dose or HVL, the MAM sensor, you don't need to change. So we have some very brilliant, I would say, people over in RaySafe in Sweden who designed these things, and robust algorithms make them very versatile and very user-friendly. You got anything to add, Justin? Did I miss anything?
You know what, one of the favorite comments that I ever heard, and I believe it was you who coined it, Even if you
Yeah.
don't know how to use an X2, you know how to use an X2. I mean, honest to Pete, you plug it in and plug in the sensor that you need, the rest is pretty much guided for you. And if you make a mistake, the intuitiveness built into the device will help guide you on how to correct it. It's pretty easy to go ahead and set it up and start using with very minimum training. I'm a biomed guy by nature. I didn't even know what an X2 was until I started working for RaySafe. And, you know, getting into this was really easy because how the way it's structured. So, yeah, I hope I answered that.
But it is versatile enough too, right? So if we have, like, for instance, a tomo exposure from mammography, there's a setup pulse, and then there's what I call the real part of the exposure, right? And you want to accumulate dose, for example, in both the setup pulse and from the real part of the exposure. So you can set the stop delay, which keeps the base unit awake, which actually keeps the system awake, looking for more radiation. So you might want to set that, for example, on a hologic machine, maybe 6 seconds. So then it captures the setup pulse and the real part of the exposure in one reading or one measurement.
Mm-hmm.
You always want to set it back though, because you don't want to wait 6 seconds for results if you don't have to. But in this case, it's kind of necessary to do that. So it is versatile. There are some settings, but 99% of the time you don't have to worry about it.
That's correct.
All righty. I'm sorry. Were you going to say something?
I'm stealing your thunder for 2 seconds, but we had one
Yeah.
from Andy about the base unit, since we were just talking about that base unit.
Yeah.
And guys, please, if you guys have questions, please throw the questions into the chat. This is where Ed and I are having fun. We're going to play Stump Ed for the next 15 minutes. So please throw the questions into the chat. We'll get to them. But there's the one, can you control the base unit from your PC? Do you want it, Ed, or do you want me to take it?
Well, of course you can, right?
Yeah.
I tend to like to control it from the base unit, but if you have the base unit and you're using it wirelessly and you're several meters away from the base unit, yeah, you can choose it. You can control it using RaySafe View.
100%.
Didn't show that when we demoed RaySafe View during the video, but yeah, you absolutely can adjust the units or change the units from Röntgen to gray or vice versa. You can set that stop delay. You can set ignore pre-pulse. That's, for the RF sensor. And then of course, any settings that are available for any of the other sensors, you can also change using RaySafe View.
100%. 100%.
Yeah. I know we got another question. Shelby, thank you for entering your question. She's asking, is there a suction cup holder for the DXR?
Oh, not for the DXR. It would not fit. The existing one for the X2 would not fit over the DXR, but that is a very good idea.
You know what though, Ed? We're going to cover in a later video that RaySafe has started to release some of our sketches and drawings, because so many people have 3D printers now that they want to print their own holders. That might be pretty good. Maybe we can take that back and see if we can get a drawing of the DXR so that somebody could 3D print their own holder for that.
Can't make any promises, but I'm sure they'll consider that back in Sweden.
Wow, great question. Wow, that is a good one.
It is.
And you're right, Justin. We are going to, reference that on future webinars. So thank you.
Mm-hmm.
I think this is from, and I hope I pronounced the name correct, Rashani. How does RaySafe X2 measure total filtration and KV?
KV, so there's stack diodes, right? So there's 4 diodes in a stack, and in the RF sensor, there's 2 adjacent stacks. So it's basically a stack sandwich of diodes and filters. And the signal to each of the diodes is affected by the filter on top of it. And I won't get into the physics behind it because I don't exactly understand the physics behind it. We'd have to have some of the more brilliant R&D people on the call. But basically, it's a ratio of the signals to these sensors that allow you to measure KV. Also, it allows you to measure HVL. And then from that HPL measurement, we can also estimate the total filtration. So if you really wanted a scientific answer to that, you'd have to consult with somebody other than me and Justin. But I think that hopefully that is a deep enough explanation. Yeah, KVP meters have been around for a long time, and there's actually a Frank Rinaldo. Hope it's okay to reference a person's name. Actually wrote a thesis when he was at the University of Wisconsin way back when, and so that's all these KV sensors are in some way harken their way back all the way back to I think the mid 80s or even late 70s. So everybody measures KV in pretty much the same way or a derivative of that from that paper. Yeah.
Wow. Okay. I think that we'll call it for the questions. Justin, is there anything else you would like to add, or Ed, before we conclude?
I'm just glad that everybody joined us today. You know, we're going to have a whole series of these. This is not the last. This is the first. I believe we have 5 more webinars coming up over the span of the next few months. Please join. If you see the webinar coming up and you have some questions, please write them down. We'd love to chat about them. We'd love to hear the questions. We'd love to answer them for you. So we can't wait to see you on our next webinar. And thank you all very much for attending today.